And this is where part 2 starts. When we add this material into depleted soils, we're allowing for the stabilized photosynthetic reaction in the humid soil to turn the entire treated area into a giant biological solar cell. The land continues to fix carbon, make water, trigger topsoil formation, gradually regenerating the soil ecosystem biodiversity. It acts as a secondary underground photosynthesis, which supports plant-based photosynthesis. The resultant impact on food production from terraforming depleted land into arable soils can be quite visual. So this picture was taken from a farm where the change occurred in about 7 months from left to right. And accompanying the change in the soil, that's the response of the plants from left to right. And in Thailand, a chili plantation went from this to this. And Australia, pharmaceuticals, left to right. And in the Philippines, growing rice from left to right. In a golf course in Singapore, sand to soil. And in China, rice grown in saline alkali soil before and after. And in Indonesia, pineapples from left to right. And here in the UAE, fodder for grazing animals before and after, just like how they do it in Malaysia, exactly the same. Depleted soils from left to right. Regenerating the soil and moisture, it drives economic outcomes, which in turn improves food security. So it's decarbonization that is driven by soil regeneration. And as the soil carbon accumulates over time, given enough time, carbon can accumulate vertically, just like in this picture. Here's a tree that's 20 years old, so you can see that original soil horizon. And on the right side of this picture, that's sugarcane, where somehow that topsoil layer is now more than 400 millimeters higher than the surrounding soil horizon. How do we account for 4,000 cubic meters of material extra per hectare? How do we do that? We've tried to quantify it. For example, here's a hyperspectral satellite picture of an area that was going through 4 years of drought in Australia. More green in this picture means more photosynthesis, and more red means soils that are barren. And turns out that treated soils over a longer period of time are pretty much completely green. So this tangibly shows the impact of that accumulating carbon. Now we can imagine a future where the farmer gains a potential new income stream. Number one, he produces food, but now, number two, his underlying soil can act as a permanent and massive carbon accumulating sink at the same time. The soil, not the crop. So case studies worldwide today are suggesting about 20 tons carbon dioxide equivalent unit sequestration potential per hectare and per year. We are working on methods to quantify this, and we're in the process of submitting a new carbon methodology to account for this. Quick recap. We upcycle organic wastes through an emissions-free catalyst production method to continue that soil photosynthetic reaction and catalyze the biological carbon sequestration and water manufacture in improving soils and therefore achieve better food security, hence leveraging organic wastes for regenerative climate solutions. All of what you've just heard has been published as a best practice in the textbook, An Introduction to Circular Economy, certified as a soil carbon amendment by the USDA, recently presented at the UN and the FAO level, awarded by the CCAC, projects in 33 countries and territories, supporting 12 out of 17 UN SDGs. So quickly, we're going to share an ongoing project with Saudi Arabia for a sense of the sort of impact in the GCC region. Here we are combining elements of the circular carbon economy framework together with the Saudi Green Initiative, which is meant to terraform 40 million hectares of soil through the accumulation of carbon into the soil carbon pool, and hence reducing irrigation needs by 50% or more. So, for less than the cost of the water savings for the project, when applied to say half of the SGI or 20 million hectares, the data thus far is pointing towards a carbon sequestration potential of 136.5% of the entire carbon emissions of Saudi Arabia at 0.8 gigatons per year, decarbonizing atmosphere through the recarbonizing of soils towards an arable Arabia, one where carbon is not the enemy and carbon is a friend. And this short presentation here hopefully provides sufficient technical context to better understand Indonesia and Jarum Foundation's work, considered to be a global best-in-class for 2023. Their decisive leadership and innovative spirit in adapting this technological tool to maximize local impact has resulted in truly amazing outcomes which has inspired many others in the ASEAN region and beyond. Do save this QR code where we openly share information, including a download of this presentation. So take a picture here and save it for later use. My name is Rowell, Chief Sustainability Officer of VRM Biologik, and on behalf of the team, the Indonesian government, and our gracious hosts, the UAE, I thank you for this opportunity to share.